Hello everyone, my name is Pradeep Bisht. I'm a student of Electronics and Communication Engineering in my final semester of b.tech. The topics I have chosen for my presentation include the networking basics, the IP address and its classification about the public IP address and the private IP address. I've also covered modem and routers and the different type of internet connection we get, DSL connection and the cable connection and the difference between them. I've also covered about DHCP server and its working, and in that I have covered the NAT table and the DNS server system. At the end of this presentation I have covered about the wireless communication and the various standards on which wireless communication operates, and I've also given information about the Wi-Fi system and the various factors on which the speed and the intermittent connection of the internet depend. Okay, let us begin with the networking basics. Now let us understand what a network is. Now network can be stated as two or more computers which are connected together. Now everyone is familiar with the word internet and everyone has experience surfing the internet. So internet is a global system which provides all kind of network services. It consists of numerous interconnected computer networks. A computer network is built with two or more computers interconnected to exchange data and share resources. The most common way to categorize network is as per the domain. Now what a domain is, it decides the range of the network.
Now, as I told you, the most common way to categorize network is as per the domain, which stand for the range of a network. It can be categorized into LAN, MAN and WAN. The LAN stands for local area network. It connects devices in a small geographical area such as home, single office or school campus, and it is privately owned and it is limited to few kilometers only. After that we have MAN, which stands for Metropolitan Area Network. It interconnects computer resources in a larger geographical area, normally a town or a city, and it covers a lane that is most probably less than 50 km. After that we have a wide area network, which is responsible for connecting multiple LANs and MANs, and it provides long distance transmission of data. It comprises from a country, continent or even the whole world. The communication between the users in a WAN is established using leased telephone line, optical fiber or satellite. Now for the devices to be able to connect to a network, they require a hardware which is normally called as network interface controller. It allows our computer to be connected to a network using either Ethernet or wireless. You can have both Ethernet and a wireless on one computer if you are using multiple NICs to connect, each one being a different piece of hardware. Most of the motherboards will have an Ethernet port built in and some other will have wireless built in as well. Now this is a picture which shows a normal NIC which is normally installed in our motherboard.
Transmitting data from source to destination is not a simple process. To help multiple vendors and the general public to be able to form networks that interoperate across many architectures, a standard model has to be derived. OSI, Open System Interconnection, is a 7-layer network model specified by ISO and is widely used all over the world. It allows any two different networks or system to communicate regardless of the underlying architecture. Now, from bottom to top, the 7 layers are physical layer, data link layer, network layer, transport layer, session layer, presentation layer and application layer. And about all these layers I would tell you about in the PPT.
Now, as we discussed, Open System Interconnection is a 7-layer network model specified by ISO, widely used all over the world. It allows any two different systems to communicate regardless of their underlying architecture. The first layer of the OSI model is the application layer. It is the end user layer. The application can be email, web browser, scanning software and so on. It is where certain parameters will be agreed upon by the programs to deal with data, like the raw data generated by a scanner. After that we have the presentation layer. The presentation layer is responsible for converting the data received from the application layer into neat binary, because computer understand only binary language, so presentation layer is responsible for converting that data into binary, and or it also represent binary into application readable data. After that we have the session layer. The session layer provides services to establish, maintain and terminate a session connection. It also is responsible for synchronizing data exchange between two devices. For a very common example, when audio and audio stream at the same time, all those components may be arriving in separate streams, but are timed so that they arrive at just the right time to make the experience seem like a single stream. We have the transport layer. The transport layer is responsible for delivering data generated from an application on a computer to the same application that is running on another computer. To differentiate which application is running on a computer, the service point address called port number is used, and the port number is a functionality of the transport layer. After we have the network layer. The network layer uses logical addresses such as Internet Protocol IP addresses for devices on the network to deliver packets from source to destination across multiple LANs. After that, we have data link layer. When receiving data from the physical layer, the data link layer will check for physical transmission errors and organize the data into frames. It also provides the physical addressing scheme such as MAC address to uniquely identify devices in LAN. MAC addresses are very relevant and are involved nearly in all network transmission. Every device have their own MAC address. The last layer is the physical layer, which coordinate the function required to move individual bits from the actual medium such as wire, Bluetooth, light, radio, etc. Wireless is a good example of that.
IP address stand for Internet Protocol Address and were introduced in 1981, and the authority that is responsible for it are called IANA, which stands for Internet Assigned Numbers Authority. Now, basically what an IP address is. IP address are numerical label assigned to each device connected to a computer network. Now, every device has an individual address that identifies it from all other devices that are connected in a network. And in turn, networks have addresses that connect across the internet. Now, IP address can be categorized into IPv4 and IPv6. IPv4 is a 32-bit long address and the IPv6 is a 128-bit long address. Apart from this, IP address can also be classified into public IP address and private IP address.
Now IP address can be classified into 5 classes, which are class A, class B, class C, class D and class E. Class A addresses are assigned to networks with a very large number of hosts. Class B for medium to large networks. Class C is used for small networks. Class D addresses are reserved for IP multicast addresses, and Class E is an experimental address that is reserved for future use. Now the following table shows IP addresses classes range. Class A start from 0 till 127. Class B start from 128 till 191. Class C starts from 192 till 223. And Class D starts from 224 to 239. And the last class 24 starts from 240 to 247. Now, even in this class range, there is a difference between a public IP address and a private IP addresses that is assigned separately in this range only. Now let us take a look upon the difference between the private IP and the public IP. Private IP are used with your local area network or network. They are not recognized over internet and are assigned by a LAN administrator. Suppose at your home you have a router, so it gives your devices private IP, and it is only unique only in your local area network, and it doesn't come with any charge. Now in public IP, it is used on public network, it is recognized over the internet, and it is assigned by the INA, and it is unique globally, and there is a cost associated with using a public IP. And now the range, as we know, we discussed the class A, B, C, D, E ranges. So the private IP is present only in class A, B, C. So from that, class A 10.0.0.0 to 10.255.255.255 is the private IP. And similarly for class B 172.16.0.0 to 172.31.255.255 for class B, and for class C 192.168.0.0 till 192.168.255.255. So these are the ranges of private IP. Apart from these IP, the rest of all the IP are used as public IP. Now let us take a look on the functionality of these classes. Class A always has its first bit as 0, next 7 bits as a network address, and the following 24 bits as the host address. We have discussed the range of the class A IP address, which means that it allows 2 raised to power 7 networks and 2 raised to power 24 hosts per networks, and they are used for a very large network. Now class B has always its first bit as 10, next 14 bits as network address, and the following 16 bits as the host address. We have discussed the IP address range, which means it allows 2 raised to power 14 networks and 2 raised to power 16 hosts per network, and it is used for a medium network like multinational companies. Similarly, class C always has its first bits as 110, next 21 bits as network address, and the following 8 bits as the host address. By looking at the IP address range, which shows that it allows 2 raised to power 21 networks and 2 raised to power 8 hosts per networks. This class is used for a small network such as small companies or college. Class D IP address always had its first bit as 1110. There is no segregation of host and network addresses. It allows multicast, which means a datagram directed to multiple hosts. Class E, the address begins with 1111. It is reserved for future use, research and development purpose. Now let us take a look on the working of modem, router, DHCP server and the NAT table. Now a modem is a device which is used for modulation and demodulation. The modem converts the traffic from analog to digital and vice versa. In a basic home local area network, the devices such as our computer, mobile phones will connect to a router. The router will connect to the modem and the modem will connect to the internet service provider. Now the internet service provider provides only one public IP to the modem. Now modem can be classified into two types, DSL connection and a cable connection. Now DSL connection runs through our home in a standard telephone lines, and its speed is less as compared to the cable connection, while the cable connection comes in the form of coax cable and its speed is higher. And the DSL connection is not affected by the number of users, whereas the cable connection speed is affected by the number of users that are using its bandwidth. Now router is a network device to route packets based on their IP address across networks. Router is a piece of network hardware that allows communication between your local home network. Now as I told you, the internet service provider gives you one public IP and the modem forward it to the router. The router just take that public IP to access the internet, and from its own end it gives a private IP address to all the devices that are connected to the router. Now a router typically connects physically using a network cable to the modem via the internet or WAN port, and then physically again through a network cable to the network interface card in whatever wired network devices you have. DHCP server is a functionality of the routers. Now a DHCP server is a network server that automatically provides and assigns IP address, default gateways and other network parameters to the client device. It relies on the standard protocol known as the Dynamic Host Configuration Protocol or DHCP to respond to broadcast queries by the clients. It consists of four main processes: discovery, offer, request and acknowledgement, and this process is commonly called as DORA. Now NAT table is also a functionality of the router. It stands for Network Address Translation Table, and it allows devices on a private network to access a public network such as the internet. There is often only one entry point between the public network and the private network, and that entry point is usually called a router. So it is a functionality of the router. Now router creates a NAT table and accordingly distributes information.
Wireless is a term used to describe a physical connection that uses radio waves to send information from one device to another. Now, wireless devices use specific frequencies to communicate with one another. IEEE 802 LAN-MAN Standards Committee develops and maintains networking standards and recommend practices for local, metropolitan and other area networks, and then apply them on a global basis. IEEE 802 are further diversified and identified by second number like 802.1 and 802.2 and so on. And finally, 802.11 is the specification for implementing wireless local area network in 900 MHz, 2.4 GHz, 3.6 GHz, 5 GHz and 60 GHz frequencies.
Now let us talk about the IEEE 802.11 standards. Now to help ensure the compliance to the FCC, which stands for Federal Communication Rules, we have a large group of people engaged in collaboration. At the very top of this group, we have IEEE. Now the full form of IEEE is Institute of Electrical and Electronics Engineering. The IEEE 802 Standards Committee develops and maintains networking standards and recommended practices for local, metropolitan and other area network using an open and accredited process and advocates them on a global basis. The IEEE 802 groups are further diversified and identified by a second number, for example 802.1, 802.2 and so on. 802.1 as already discussed is the specification for implementing wireless local area network. The 802.11 groups are further identified by a letter, so I am just discussing few of those standards. The 802.11a was released in 1999 and it works on the frequency of 5 GHz and the maximum data rate that it can transmit up to is 54 Mbps. Similarly, after that we have 802.11b, 802.11g, 802.11n, 802.11ac and the latest one 802.11ax. So all these either differ in the speed they provide or on the frequency they operate. Now the difference between the 2.4 GHz and 5 GHz is that 2.4 GHz provide you a connectivity up to a longer distance, but the speed is less as compared to the 5 GHz. The 5 GHz does not have the option of longer connectivity, but it gives you the best speed. Now a device such as our phone, laptops are able to connect to a router's Wi-Fi because our router have a functionality called wireless access point. The most common type of wireless device in most homes is a wireless router, as we know, which is a device that has the capabilities of a router and a wireless access point. An access point is a networking hardware that allows us to connect to a wired network through a wireless connection. Most of them are able to utilize two radio interface, each one for a specific band, that is one for 5 GHz radio and one for 2.4 GHz radio. Now let us discuss about the point of interference. The radio signals from the router radiate away from the antennas, and depending on the strength of the signal, there are many things that we cannot see but work against a clear reception of the radio transmission. That's why sometimes what happens, you get slow speed or you get intermittent connection. Now the possible factors are: first, due to reflection, the waves bounce off the walls and you are receiving both the main signal and the reflected signal from the access point. The absorption, certain materials can absorb the radio waves, causing you to receive a weak signal or no signal at all. That's why it is suggested that whenever you keep your router at your place, so you shouldn't keep it near to those devices or material which absorbs the signals. After that we have multipath. The waves bouncing off the walls cause you to receive both the main signal and a delayed reflected signal from multipaths. And lastly, the diffraction. And opening separated two pieces can change the nature of the wave. This is by things like doorways and windows. Due to all these factors, we sometimes face the problem of slow speed.
At the end, I would like to thank my HOD for giving me the opportunity to conduct this presentation.